Yes, welcome back to the session. In this video, I'm going to discuss about law of conservation of energy for freely falling body. Okay, so look at the diagram here. So this thick line is called ground. So clearly I mentioned this is the ground and this is the object. So here position of the object is A. So this is the object which is located at some height h. So height of the object is h from the ground. Let us assume initially the object is at rest state. So whenever the object is at rest state, we can say that initial velocity of the object is 0. Okay, so what we are calculating here, law of conservation of energy for three different locations. Okay, so the first position is A. So the object is at rest state. So I'm writing here at point A. At point A. So initial speed is 0. Whenever initial speed is 0, we know that the kinetic energy at point A, KEA is equal to 0 because of initial speed is equal to 0. What is the potential energy at point A? So potential energy at point A is equal to this body having a mass m, acceleration due to gravity was acting downward direction and height is h. So potential energy at point A is mgh. Okay, so we know the kinetic energy and we know the potential energy. Therefore, total energy at point A is equal to sum of kinetic energy at point A plus potential energy at point A. So kinetic energy value is 0 plus potential energy value is mgh. So therefore, total energy at point A is, finally we got mgh. So this is the total energy of the object at point A. Okay. Now what I'm doing here, so I'm just releasing this object. So whenever I'm releasing this object, then what will happen? This object will fall freely, right? Definitely it falls freely towards the earth surface. Let us assume after 2 seconds, the position of the object is, let us assume B. So whenever it covers a certain distance, let us assume the rest of the distance from the ground is h. Okay, so here the total height minus the object covers height is here h minus h. Okay, and during free fall means acceleration due to gravity is positive. Okay, so at point B. So at point B. Okay, so initial speed of the object is 0. Whenever the object is falling freely means definitely velocity was present. And also it covers this much distance. Acceleration due to gravity also present. So we will use third equation of motion, that is v square minus u square is equal to 2as. Okay, so from this v square minus u value is 0. 0 is equal to a is nothing but g, s is nothing but height. How much height it covers? H minus h. So instead of s, I'm taking h minus h distance. So from this v square is equal to 2g into h minus h. Okay, so this is the velocity of the object at point B during free fall in this direction. Okay, so whenever velocity will be present, definitely kinetic energy also will be there, right? So now I'm going to calculate kinetic energy at point B is equal to half mv square, right? So this is the v square formula. I'm going to substitute here. Therefore, kinetic energy at point B is equal to half m into v square means 2g into h minus h. Okay, so this is the kinetic energy of the body at point B. Okay, then what about potential energy at point B? So potential energy at point B is equal to mg into h. But here, after reaching at this location at point B, the rest of the height is small h only, right? So that's why I'm writing here mg into small h. So we know the kinetic energy and we know the potential energy. Therefore, total energy at point B is equal to sum of kinetic energy at point B plus potential energy at point B. Okay, so kinetic energy at point B is this much. How much? Half m into, one second, yes, half m into 2g into h minus h plus potential energy is mg into small h. Okay, so this half m into g is multiplied with capital H as well as multiplied with small h, right? Let us see the next step. Here itself I am writing 2 to cut. The rest of the equation is mg into capital H. So total energy at point B is equal to mg into capital H, minus will be there, so minus mg into small h plus mg into small h. Then what will happen? So this minus mgh plus mgh cut, the total energy at point B is equal to mg into capital H. Okay, only this part. Okay, so look at the derivation carefully. At point A also, final energy we got mg into capital H, and at point B also we got total energy is mg into capital H. Okay, so this is the position of the object, right? Now suppose after some time, then what will happen? Definitely this object is falling freely, right? So after some time, let us assume the position of the object reaches exactly ground. Okay, so that is, I am assuming here point C. So at point C also I am going to calculate kinetic energy as well as potential energy of the object. Okay, just a second. So this is the position of the C. I'm going for next slide. Yes, at point C. At point C. Okay, so I'm using here again v square minus u square is equal to 2as formula. Okay, so just a second. So this is the position of the C. Whenever it reaches at point C, the total height covered by the object is only capital H, right? Because initial position is this one and final position is this one. Okay, so it covers capital H height. So therefore, v square minus u square, u value is 0. So v square is equal to 2g into capital H. So if we know the velocity means easily we can calculate kinetic energy. So kinetic energy at point C is equal to half mv square. Okay, so v square formula we know, directly you can substitute here. Therefore, kinetic energy at point C is equal to half m into v square means 2g into h. Okay, so 2 to cut, the rest of the equation is kinetic energy at point C is equal to mgh. Okay, just a second. Yes, look at the diagram. Now the object is at point C, right? So whenever the object touches the ground, there is no height, right? There is no height between the ground and the object. So capital H becomes 0. So whenever height is 0, potential energy at point C is equal to 0, right? So we know the kinetic energy at point C as well as potential energy at point C. So total energy at point C is equal to the sum of kinetic energy at point C plus potential energy at point C. So kinetic energy formula is here mg into capital H plus potential energy is 0. Therefore, total energy at point C is equal to mg into capital H. Okay, so I'm coming to the diagram. Look at the diagram carefully here. So initial position of the object is at point A. Object is at rest state. So we got a total energy is mgh. So that is this one here I mentioned. Okay. Similarly, when the object is released, after some time, the position of the object reaches point B. So at point B also we calculated kinetic energy and potential energy, but the total energy is in the form of mgh only. Okay, so look at the last step here. Okay, again the body is falling freely. Again after some time, definitely the object touches the ground. Whenever the object touches the ground, total height becomes zero because there is no height from the bottom of the object to ground. So potential energy is zero at point C, but due to maximum velocity, kinetic energy was present. So finally, total energy also we got mgh. So at point A also mgh, at point B also mgh, and at point C also mgh. So whenever an object falls freely, according to law of conservation of energy, being freely falling bodies, for each and every location, the total energy is in the form of mgh. Mgh means in the form of potential energy only.